Hello, everyone. This is Expert Talk with Tobias, Test Results AO, and one of our guests. Today it's Yusuf Tayman, and he is actually an interesting guest because he has a completely different approach. He's talking about chaos engineering in testing. That's something that you don't typically hear much these days. More you hear about AI and stuff like that, but chaos engineering is actually what happens in the real world. But before we start into the discussion, Yusuf, it's brilliant to have you on the stream, and perhaps you could introduce yourself to the viewers a little bit.
Thank you, Tobias. Thank you for having me, and it's a pleasure to be here. And as you pointed out, this is Yusuf, and I've been exploring the world of testing roughly 7 years. My niche is in the fascinating fields of observability and also automation, but truly my passion, if you ask me, it's chaos engineering and observability in testing code.
Yeah, perfect. So those are two important topics, right? Observability is hot right now. Everybody's talking about open telemetry, about
Yeah,
observability. I guess most of the people are not doing it right at the moment, but that will change over time. But seeing observability and testing together is in my eyes, a brilliant combination. But talking about the chaos approach, that is something again that I think our viewers didn't hear that often yet. So perhaps you can explain a little bit what that actually mean. Like what does it? What is chaos engineering?
that's a tricky one. Normally, let me start with the testing perspective as a chaos engineering. Normally, as a QA, you can say, what are you doing with observability or chaos engineering? It's actually a legitimate question. But in general, we are responsible for the reliability of applications, you know, that and end user interaction. When we back into the past, before the as companies shifting it to the cloud, there were not such complex structures, and we didn't not think about it. The complex structures, distributed systems, but now we are faced with such complex structures that we don't know at which point what error will occur. You know. Uh, I can explain the chaos engineering with the Murphy's law. One of the Murphy's law tell us whatever can go wrong will go wrong at the worst time, and it's actually a summary of the our work and the chaos engineering. We should be prepared for everything before we face the uh, issues. And normally, before the distributed systems, we have a known knowns, and we know the everything. What will happen in our system and what is the errors, but in these scenarios, in this world, and in the distributed systems world, we cannot know everything. And yeah, at this point, we need to adopt the chaos principles. This is basically chaos engineering perspective.
Okay, so that is actually good. That is good insight. So you mean chaos engineering is more or less like to identify potential, let's say, problems in heavily distributed systems. Actually, like if you use serverless functions in AWS, or if you use Kubernetes
Exactly.
clusters that just scale automatically, or actually not scale if you need it. I guess.
Yeah.
So talking about chaos engineering, because that is a rather new topic for me actually. What are the tools that you typically use in this chaos? It's actually interesting. I can put chaos in front of every single term with this chaos approach.
Yes, chaos approach. First, before point out the tools, we need to adopt the chaos principles. It's the thing is that just adopting these chaos principles doesn't work. We need to apply them somehow, and we can use AWS fault injection tool, which is allow us to some chaos scenarios. You can perform fault injection based on the chaos engineering principles. And also with this service, you can actually subject your services on AWS AWS systems with many scenarios. What can you do? You can start and stop your instance at the some time, and you can interrupt your spot instances, and you can create CPU stress on specific instance, and yeah, there are one or two more similar scenarios with the you can use the AWS fault injection, and also there are many tools actually, and I can say that I'm using the K6 disruptor. K6 everyone knows about the load testing tools, but K6 disruptor also allow us to test the resilience on your application, disrupt uh, some of the pods or services, and you can inject some delays in the HTTP request, something like that. And also, uh, you can use Gremlin or Chaos Monkey. This is one of the some of the tools chaos engineering you can apply on your application.
Hey, Yusuf, in a sense, like you explained it, um, because you mentioned load and performance testing. For that, actually, people use tools, and that is a given that you need to do load testing, you need to do performance testing. But as I understand you, actually, the chaos principle, so testing against the chaos principle, like just bringing a network down or delaying responses, and that is something that happens on a daily basis, right? If you are surfing on your smartphone, you are changing network, stuff like that. I guess you have a delay in the response. So shouldn't we do a lot more of this chaos testing then? Because everybody's investing in performance testing, but in the end, they are testing for this 1 or 2 big days in their e-commerce shops or whatever, which I guess is controllable. But for what you mentioned, like those delays in the response, that is what I see on a daily basis. So like server behave different, the response times are different, networks are going down, there's some takeover from a different network. So shouldn't we all not do a lot more of this chaos testing?
Exactly. We have to add these chaos approach on our pipeline as well. And because the you know that the traditional testing, let's talk about the automation. We are focused on known issues and predictable scenarios. But the chaos engineering test or chaos principles uh, allow us to see unpredictable and random events. And yeah, uh, we have to add these tests or these principles or this approach in our pipeline. It's not also our responsibility. It's not only the testers or test engineers' responsibility. We have to apply for all of the team, because you know that the developers configure the logs, metrics, and traces on on the application level, and the DevOps team also build monitoring systems or observability systems, and also security teams build these tools as well. And we need to embrace all of these things with together, not only the creating.
Hmm. So chaos, the chaos approach in testing should be standard in our pipelines. What I understood right from your answer right now is like, okay, the chaos testing is one thing, like inducing unexpected failures, the unexpected more or less. Um,
Yeah,
The other thing that you mentioned in the answer is observability. So what I understood from what you said is like chaos testing is one pillar of it, but in the end you need to pair that with some kind of monitoring, logging, so like everything that we call observability these days, right? Otherwise you don't get any insights from the chaos testing. Is that right?
exactly. If you do chaos testing in one hand, we cannot understand the whole picture. So, and also one thing as well, when we talk about the observability, generally the people confused about the monitoring. Let me explain first the monitoring and
Mhm.
observability difference, and then we can talk about how will we see the whole picture. Normally, people understand the monitoring as observability, but seeing the difference between monitoring and observability actually means solving the whole things. But there is a quote from the Sherlock Holmes. There is a famous quote: "You see, but you don't observe." It's really explained monitoring and observability. And yes, we can see that something is going wrong. CPU has increased and database is under load. Yes, we can see them, but we don't know the reasons. At this point, there is only one thing that is important: to see the whole picture. And for this, uh, to see the whole picture, we have to adapt the observability as well. We have to adapt the three pillars of the observability: logs, metrics, and traces.
And you do have, I think you have the nicest metaphor that I ever heard about those different pillars, like logs and traces. Is like you always compare that to some kind of RGB lens, right?
Yes, and we can say that we can explain it like that. You have a picture of your application, or
Hmm.
you get an error. You need to ask some questions correctly. Let's say we have a RGB lenses and we have a one picture, and you are making examination with these lenses. What you will see in the red lens, for example, let's say the red lens, in some shadows you will see some shadows of the picture. With these shadows, we will able to understand what the picture actually looks like, and these lens actually represent, let's say, the logs for us. And you can say that yes, there is a problem, and we can see on the logs, but also we don't know where it comes and which users are affected. And at this point, we have to jump to the green lens, and we have to look at the picture with the green lens. When we look at the green lens, it allows us to see a little more details. We can think that it actually expresses metrics. Let's say the metrics. From here, we can understand what logs, what errors, and we get from the logs and which users are affected in how long, and also you can see some of the other metrics as well. But still, we don't know, we don't understand the problem. And for this, um, we have to jump to the blue lens. When we look at with the blue lens, we can now master the details lying in the shadows, and we can actually find the source of the problems with the traces. Because when you connect it with the traces, you can see which services affected these problems, or which endpoints having a problem. And now, when we bring all these lenses together, this is now called observability. And you see the real picture. It's all about how you connect everything with each other. And if you look at only one point, you will miss a lot of things. But if you combine all of these three lenses like a master painter, you can see beyond the surface, and you can see the application soul, you know?
Yeah, I honestly, I just love that metaphor. It's really like it explains observability that brilliant, and I guess everybody can understand that. That is.
Exactly.
I would already call it that's a masterpiece, but it's too small for a masterpiece. But it's a brilliant piece. Actually, it's a brilliant piece. The thing is that I'm asking myself is again, um, yeah, we are both in that business, and you are doing that for a long time already. But as I mentioned in the introduction, it's like observability. I guess most of the testers are not yet there where they do have access to like these three lenses combined, right? What they might get is attached logs, for example, if they get anything.
Yes.
And also for the chaos approach, honestly, I don't know any tester that I've ever seen in any product or project that I've attended to that said like, yeah, we do the chaos approach in testing. So I see the need for both of those combined based on the discussions that we have. And I see that that should be actually one of the highest priorities to bring that into testing. So if I'm a tester that didn't use chaos testing or chaos approach in testing ever before, and I have no clue about observability right now, so I have
Yeah.
two big gaps in the end. Like, do you have some actionable tasks that I would need to do in the beginning? Like, how would I start?
Uh, I will explain for myself. I've just started to. I started with the chaos engineering principles and chaos engineering best practices. First, I learned the chaos engineering best practices, and then learned the chaos engineering principles, and then I learned about the chaos tools. Then I saw that if you learn the chaos tools, and you will adapt to the observability as well, because uh, you cannot do anything with the only the chaos testing tools, because if you don't have observer, you cannot see anything about that. And yeah, these are my main starters.
Yusuf, amazing, amazing. The thing is, so you heard it here first. Start with chaos engineering and then go to observability. By the way, I love how you say like there are the chaos engineering principles, right? Apparently, also
Yes,
in chaos, there are some principles that you have to follow,
exactly.
which, in a sense, but that is brilliant. Any final advice to our viewers? And honestly, I love that episode already right now because that is something that you don't hear that often, and that is something that you have. I think you have huge takeaways starting that from starting that to bring that into the pipeline of testing, and you'll see a lot of insights and benefits.
Exactly.
Any
One
other
final
anything else
thing.
that you want to mention?
Yeah, one final thing I can say that just understand your system behavior, and then simulate your real scenarios, and minimize the impact for when you are doing the chaos experiment, because you can broke some things in your test environment, and if you are doing this on production, yeah, we have to minimize the impact. That, that's it.
But that's actually that brings me to another question. Actually, sorry for that. So I have to steal a bit more of their time. That's an interesting point. It's like because you do have a production environment and you do have a qual and a test environment, for example. So how
Yes.
and most of the times what I see at customer side is like they do have the production environment, which is completely set up in a different way than the qual and test environment. Which shouldn't be the case, but in reality, you often see that like in production everything can scale. In the test environment, yeah, you have one server that it just doesn't scale. So how do you actually circumvent that problem? Because I guess you cannot use chaos engineering principles if there's only one single server. So if you unplug the Ethernet wire, the traffic is just gone. But if you have a scalable system on the production side,
Yes.
I mean, system will recover each other. So what would you actually advise on that? So if a tester says like, yeah, but in tests we cannot use chaos engineering because we just have a single system and we don't have anything else.
Yeah. I I will answer for myself as well again. And from my side, we are doing the test environment for this chaos testings, because we have to minimize impact, and we don't want to impact the users, the real users. But if you want to do this on your production, um, you have to really be careful about that. You have to really design well designed systems and you have to work with closely with DevOps or security teams as well. And these are my concerns, and these are my insights for this.
Yeah, I see the point. That's a good point, isn't it? Like, if you find a problem, you should have somebody of those DevOps engineering teams and cybersec teams on hand, so that they can actually ensure that that doesn't create any bigger problems. But again, I love the
Like,
approach, and thanks for all of your insights. And Yusuf, amazing episode this time. That is really something that a lot of people don't have on their radar. A lot of people are just talking
yes,
about AI and Gen AI and stuff like that. But like this real, like getting your
yes,
hands dirty on
yeah,
stuff that is really useful in finding things that actually affect end users every single freaking day. That is amazing. Thanks for all of your insights.
yeah. Thank you very much. Thank you for having me. This is the you know that everyone talks about the AI, Gen AI. That yes, these are also really important topics, but this is the reality, you know.
Yeah, exactly. That's the point. That's the point. And people lose some traction of reality. They talk about like I don't know, like castles in the air, where you say like, yeah, that is amazing, but this chaos approach actually, I see the real benefits in real life, in real scenario, for real projects, for real customers, and that is something that you can
Exactly.
start implementing tomorrow, right? It's not like you need to have some fancy AI LLM model that you need a license to and need to somehow integrate and put on top of your current solution. No, you can put chaos approaches in your testing pipeline just starting from tomorrow, if it's not the weekend for you. But
Ex
nevertheless, I mean, that
yeah.
is the point. And Yusuf, again, thank you very much for being on the stream, and looking already
Thank you
forward
very much.
to your next presence here with us, because that is a topic I think we just started to look at on the surface of it, right?
Exactly. Yes.
There's a lot
Yeah.
more to
Thank you
that.
very much.
Thanks again,
Thank you.
Yusuf. Bye.
Bye.